All right, here we go. Where were we at? Is it working now?
Yeah.
Good, okay, here we go. What's 3 minus 1? This is 2. So you get that 2x squared, and then you got, fractions are back? Yes. You have some work to do, ladies and gentlemen. Your fractions, very often, this is a pretty good exercise in you going over work with fractions, some arithmetic, because you really want to be good with your fractions. Okay, you want to be able to add and subtract fractions. So let's try this out. Right, what's negative 1/2 plus 1? I'll do my work over here. So if I have to do this, negative 1/2 plus 1, if you guys remember, you might be used to only doing what? Adding fractions with different denominators, right? So put a 1 here. Now, you guys remember your procedure? Or how do you want to do this? Should you use the shortcut? What's the shortcut? You can only add what's called like fractions. So this is 2 and 1. What denominator do you guys want to really have? So remember we did this? I said, what did I do? Put this as 2 over 2. You guys know what that means? That's 1. 1 times anything is itself. So when I multiply these two fractions, what's your new denominator going to be? It'll be negative 1 over 2 plus 2 over 2. Is that right? Then this is negative 1 plus 2 over 2. What is this? It's 1/2. So the work you did here says that we replace this with a 1/2, and that's positive, by the way, and then we still have our x term. So this is how we're combining like terms. This is every detail. And then I got to take a 2 minus 3/2, another fraction problem to do. Okay, so I have 2 minus 3/2. Let's do this here. 2 minus 3/2. I subtract what? What's my denominator here? Wow, this one's 1. What do I want this to be again? I want it to be a 2. So what am I going to do then? You guys know? What do I do to make this denominator here a 2? You could use the same trick. Multiply this top by 2 and the what? Bottom by 2. All right, what's 2 times 2? Is that 4? What's 2 times 1? Is that 2? So 4/2 minus 3/2, what does that give you? 1/2. So that'll be plus what? 1/2, okay? So here's your final answer. And yes, they can give you what? Fractions. Okay, you okay with this? All right, here we go. Can I erase this here? You guys have that in your notes? Can I erase this here? Oh, okay. No? Okay, we'll give you a few seconds. A few seconds or 2 seconds, right? 1, 2. Okay. Let's get this. Okay, here we go. Let's give you another example, just so you guys can put this together. What if they gave you 3x squared minus x plus 4, and then they put down here x squared plus 2x minus 7. And then they put an addition sign here. Do you guys know what you're looking at? What are you looking at? Yeah, do you guys know? We don't just add horizontally, left to right. We can also add what? Vertically. So you can kind of line up these terms here, right? As what? X squared. Line up these terms as what? As x. These terms are lined up already, in a way. But they're going to give you a value, a constant, right? So how do you guys add again? You're going to take your what? Your 3. What number's over here, by the way? 1. Good. There's a 1 there. So we're going to add vertically. What's 3 plus 1? Is that 4? So this is 4x squared. And then what number's here? 1. Well, not 1. It's what?
Negative 1.
Negative 1. What's negative 1 plus 2? Positive 1. Good. What's 4 plus a negative 7? It's negative 3. Okay, you guys okay with this? Now I want to say to you a couple of things here. What are you really looking at as an answer? Because you know you're adding and subtracting. You can't add these terms anymore. These are not like terms. But then what is it that you're really looking at? I'll put this over here. I'll put this definition since you're probably done with the work, right? What you're looking at, by the way, is what we call a polynomial. So I'm going to give you the definition here of a polynomial. I'm going to start off really simple with this. I know it doesn't look simple, but a polynomial looks like this. an xn plus an minus 1 xn minus 1 plus an minus 2 xn minus 2 all the way down to what? a1x plus a0. Okay? Now, you see all these subscripts with an n and this an. I'm going to tell you guys that an and an minus 1, an minus 2, all the way down to a1 and a0, these are called constants, while constants is a fancy way of just saying numbers. So they're numbers. In the same way that 4, 1, and negative 3 are what? Constants or numbers. Okay, you see what I'm saying? They're constants. Now, the variable that you have here is what? X. So we have our variable x. So this is a polynomial in terms of the variable x. What else do you guys know? What about this thing? You see this n? Well, n is what we call the degree of your polynomial. And the degree is simply the highest what? Power. So your highest power is n here. That's the highest power. Okay, what else do we want to say? Notice this. What's the degree of this polynomial here? What's the highest power?
The second.
Good. So this is a, what's the degree then? The degree is 2. Okay, the highest power is the degree. Also, let me say this, that we have n minus 1, n minus 2. Do you guys know how that works? How does that behave? What do you think? Well, what power belongs to this x? We may not know. I'm going to tell you in the future. Let me tell you. You guys don't know yet. This is the power 1. So what I'm going to say to you is, typically, when you give your answers, you know, people say, or always ask, does the order of these terms that I write down matter? Remember, we had that question. I said, no, not really. It doesn't matter at all. That's true. It doesn't matter. But we like to write our answers in terms of what we say, descending powers. What do you guys think? What does descending mean, you think? Yeah, descending is when you go how? Down. So you're going from a higher elevation to a lower elevation. You're descending. Right? So this goes from a power 2 to a power 1 as we read left to right. So we call this a descending power. So we write this here. If you notice, this is also given to you in terms of what? Descending powers. When you die, what do you want to do? Do you want to descend? Or do you want to ascend? Good.
It will depend. If you're a Christian, you will ascend.
You ascend. Yes. What does ascend mean? You go up to where?
Heaven.
To heaven. You okay? That's ascending, going up. What's descending? You don't want to do that. You're going down. Well, I'm getting cremated, so.
It's cheaper.
Oh. Let's not even go there, but yes, it is cheaper. I'm getting cremated, and I'm getting cremated for free because I'm donating my organs. That's why I'm taking care of my kidneys. You may want it one day. Okay, so I'm not gonna descend in any way. I will be scattered and hopefully I ascend. Okay? Scattered? No, I don't know. I used to tell everybody, hey, I used to tell my family, just scatter my ashes in Dodger Stadium, put it in the infield. Just run out in the stadium and just go crazy with my ashes. Isn't that a cool idea? Just go leave my ashes in the infield.
There was one guy, he did that in the Phillies.
He did that? He left some ashes?
Yeah, because he ran to the infield and he was like throwing ashes.
Is that right?
Yeah.
I thought I was the only one with that idea.
Because his mom, he was like a huge Eagles fan.
His mom was what?
A huge Eagles fan.
Oh, well.
That's the reason why he did that.
In all honesty, you can leave my ashes in the ocean somewhere. Okay, you guys ready? Here we go. As long as you understand the concept of descend and ascend, here's what I'm going to say to you. Here is a polynomial. X to the fourth plus 2x cubed minus 3x squared plus 6. Here's a polynomial. I'm going to have you add that polynomial with another one called 3x cubed minus 2x squared plus 7.
Quick question, Judge.
Yes?
When you put x to the third power, why do you say cube?
It's another way of saying x to the third power.
Isn't the cube like made of a square? So that's 4 sides.
Yeah, when you say square to square a value or a variable, it's raised to the power 2. When you say cube, it's raised to the power 3, essentially. But is there more detail to that? The answer is yeah. It's related to a area of a square is side times side. And the volume of a cube is side times side times side. So that's where they get the cube idea. It's related to it's actual cube, formula for volume, and for a square, it's area. So it's side times side. That's where they get it from. Okay? So, how if we change this? Let's say plus 7x. Here's what I want to say to you. Is this a polynomial? Yes. What's the degree? 4. Good. Is this a polynomial? Yes. What's the degree? 3. Okay, good. What operation is this? Right? What did you guys see? What did I just erase? This was what? This is the plus operation. What is plus also known as? The addition operation. So what's the title of the worksheet? Add, subtract, polynomials. You got 2 polynomials here, right? So here's how you do this. When you're going to add polynomials, just remove your parentheses. Okay? And so you say, if I do that, I have x to the fourth plus 2x cubed minus 3x squared plus 6 plus what? 3x cubed minus 2x squared plus what? Plus 7x. And now I'm going to say what to you? Combine what? Like terms. What terms are like? Let's scan through this, right? You got what? X to the fourth power. Are there any others? No. What comes next? X to the third. Third, sorry. And then what comes next? X squared. And then, I'm going to start to do my squiggle. And then a what? Double squiggle. Okay, because I want to visualize what's like and what's not like. So let's see. Don't I just get what? X to the fourth now. And I got 2x cubed plus 3x cubed. What do you got? Is that 5x cubed? Okay, then I got a minus 3x squared and a minus 2x squared. What do you got? Minus 5x squared. And then I can't combine my 7x because there's no other term that's exactly alike. And I can't combine my constant because there's no other term that's exactly alike. You are done. you get, again, a polynomial with a degree, what? 4. Okay? So you're adding polynomials. We're also doing what? Subtracting polynomials. So can I get rid of, you guys have that? Okay. So let's subtract these polynomials. Here we go. I'm going to put in my parentheses, right? So I'll put, let's do something simple like a negative x cubed. Or we'll do very simple. Negative x squared plus 3x minus 6. Subtract 2x squared plus x minus 4. Now, you know this is subtraction because what do you see here? The minus sign means to subtract. So let me explain to you the procedure for subtraction. It's very simple. It's not the same as the procedure for adding. For adding, simple. Drop your parentheses, combine like terms. Here, you drop the first set of parentheses only. Right? You got minus x squared plus what? 3x minus 6. What do you do now with this here? Yes, you do. In other words, you're subtracting every one of these 3 terms. You're going to subtract every one of these 3. What that means is I'm going to change the sign of each what? Of each one of these terms. So minus a positive 2 means what? Write the opposite sign. What's here? This positive 1x is now a negative 1 what? X. Negative and negative. Is that true? What's the opposite of a negative? Positive. So you're changing the signs. I'll even put that in your notes. Change your what? Signs to the opposites. You got to have opposite now what? Signs.
We're only changing the signs to the Subtraction.
For the second one that you are subtracting. Yes. The first, no change. All right, you guys okay with that? That's the procedure. So let's see what comes next then. What are you guys going to do now? Combine what? Like terms.
It might be.
Is that your car?
It might be.
Uh-oh. Hmm? I just say just buy the low jack. Invest in low jack. Someone takes your car, just call police, get your car back. Well, what do you guys have? Negative x squared minus 2x squared. What's that? Remember, shall we go through this like we've been doing? Isn't this term like x squared and x squared exactly alike? Same symbol. X, same symbol. The constants, my money, same kind of symbol. So let's see. We got negative x squared minus 2x squared. I owe an apple. I owe 2 apples. I now owe what? 3 apples. I have 3 bananas, and I owe a banana. I'm going to have 2 what? Bananas. I owe $6, and I have $4. What's going on? I owe what? 2. You guys okay with this? You guys okay? How many car alarms is that now?
Yeah, everybody's going crazy.
I think because there's this car passing
They were
by
mad,
really
yeah.
fast and bumping like super.
This is so funny. It just happens all the time.
No.
All right. What do you guys notice? Is this descending order?
Yeah.
Okay, descending order, you get a polynomial. This is how you subtract. Okay. Yes, question?
Why is it that when you subtract, you have to change the second instead of the
You guys want to know, really want to know why? Because you know that negative sign here? Right? You see this here? it's a -1. In other words, they remember, whenever you see a negative sign like this, they got lazy. It should be a -1 what? Times. So it's really that distributive property here that's going on. How do I remember it? Change the signs to the opposite. When you what? Subtract. When you add, you just drop the parentheses. Okay? And so they can give you problems that are even subtraction that are not just horizontal. They can even give you vertical problems. Like, so for example, they can say to you, what happens when we have a 3/2 x squared plus 2x minus 1/5, and then they have 1/3 x squared minus x plus 1/2, and now they want you to do this sort of thing here. Now the book, or this worksheet, puts a parentheses here. Let me double check. Oh, I gave the gentleman again my worksheet. Let me see, I took a picture. I'm pretty sure that's kind of what they had there in that worksheet. Yeah, the question then is, like on this worksheet, oh, I don't even see it. Anyway, the question is, what does this mean? Do you guys know what this means? Here's the top polynomial. Here's a what? Bottom polynomial. And you're supposed to what? Subtract them. In other words, just change your what? Change the signs here. And change them to the opposite signs. So what happens is you get now what? 3x squared plus 2x minus 1/5. That positive 1/3 is now what? What is this? Negative 1/3 x squared. What's the opposite of a negative? What's the opposite of a positive? Negative. Okay, so here's what they want us to do. Again, notice that you're lining up all your what? They gave this to us. Oh, is that vertical? Vertical subtraction. Line up your terms. You got the x term. This is just your constants, by the way. What I'm saying is that, which one's the easiest one to do? I think 2 plus what? Plus 1. What's 2 plus 1? That 3. And notice that 3 is positive, right? What do you guys know? What do we have to do? 3/2, negative 1/3. Do your what? Your work. Your work consists of, what's the work? I got work to do here. 3/2 minus 1/3. So I got 3/2 minus 1/3. So, ladies and gentlemen, you may want to consider your procedure for subtracting and adding unlike fractions. So you want to go through that, okay? So notice there's a lot of arithmetic here with fractions, right? So the expectation is that you guys will be good with this arithmetic. So when you go to Math 1, what comes next? 125, you guys will have your fractions out of the way. So what's the LCM of 2 and 3? Right, don't you need the LCM of 2 and 3? So you can put your 6 down here. 6 over here. We get 3/2, we get what? 1/3, so let's think. 2 times what is 6? So we can put 2 times 3 times 3. 3 times what is 6? 2 and 2. You guys remember this format? So it's back. You guys want to be experts with this. 3 times 3 is 9. 1 times 2 is 2. I get 9 minus 2 over 6. What's 9 minus 2? 7 over 6. So the work I did here gets placed 7, 6. I now have to do some work with what? My negative 1/5 and my negative 1/2. So let's do that work. All right, let's do the work for the other fraction problem. We got negative 1/5 minus 1/2. Negative 1/5 minus 1/2. We're reviewing these fractions. If you guys remember this procedure I gave you guys, right? Where does the negative signs belong to? Let's put that negative sign on top, right? So we go negative 1 over what? 5 minus 1 over 2. So what's the LCM of 5 and 2? So there'll be a 10 down here and a what? 10 down here. This is negative 1, 5, 1, and 2. So 5 times what number is 10? 2. 2 times what number is 10? 5. So I got negative 1 times 2 is what? Negative 2. What's 1 times 5? So what is this? Negative 2 minus 5 is? Negative 7/10. Okay? And that negative sign belongs at that same level. So negative 7/10. Let me write this down here a little clearer. And so you have actually done a subtraction problem that's vertical. And this is what they want you to do, is add and subtract your what? Your polynomials. Okay, you guys okay with this? Okay, what if they give you, because they may, on this worksheet, oh, I gave away the worksheet. What if they do the following? I guess, what can I use? Anybody know? What do I use? Can I use this portion of the board? Okay, just in case they give you this, and they might. For example, what if they said 1.25x plus 3. Oh, I can't even. I don't have space. Can I use that space? Do you guys have that already? Or could I use this space? Can I use this one? No. Can I use this one? Okay. So let's give you another example. You guys know where I'm headed with this? 1.25x squared plus 3x minus 1.4. Okay, plus 6.5x squared minus 1, well, let's say minus 1.5x plus 3. Okay, and if you want it in a polynomial format, okay, put your parentheses here. Put your parentheses here. You guys already know, just drop your parentheses. So you got 1.25x squared plus 3x minus 1.4 plus your 6.5x squared minus 1.5x plus 3. What do you guys do now with this? Combine like terms. So the x squareds are exactly alike. The x's are exactly alike, right? And your numbers are exactly alike because they're numbers. So what do you guys notice? Bless you. What's happening here? Let's write this all down. For the x squared term, here's my x squareds. What do I have? 1.25, is that right? Plus what? 6.5. That's for the x squareds. Now go to the x's. Plus 3 with what? Negative 1.5. That's an x. And then I have this minus 1.4 plus my 3. The point I'm making is this time you have work to do. What's the work? Here's your what? Here's your work. Here's your work. Here's your what? Here's your work. You have some arithmetic to perform. So you're going to have to bring out your algorithms associated with addition of what? Decimals. You guys remember how to add decimals? What do I mean by the algorithm? Yes. Good. Did you color that worksheet?
Yes, you did.
You did? Good. 1.25. So good. You line up your decimals, right? Now, if there's a blank space, what do you put?
5.
Put a 0. So what's 5 plus 0?
5.
What's 2 plus 5?
7.
1 plus 6? 7.75. So this is going to be 7 point what? 75x squared. And then what's the algorithm for subtraction?
Do the same thing.
Yes, it is, but that's 3.0, and you got a minus 1.5. You're lining up your decimals again. You got to bring out that algorithm. So line up the decimals, put down the decimal. 0 minus 5. What do you guys remember? You're broke. You got to borrow from your who? Your neighbor. Now what's 10 minus 5? That's 5. What's 2 minus 1? So this will be what? 1.5x. And then, what do you remember about this last piece of work? Negative 1.4 plus 3. Can I just write it as 3.0, 1.4 with a minus? In other words, is negative 1.4 plus 3 the same as 3 plus a negative 1.4? Is that the same? Yes, because the order in which you add does not what? Matter. Just keep the sign in front of the number. 1.4 is negative. So if you had $3, right, you're going to go buy some lunch. What are you going to get for lunch? Some French fries. $1.40, you have $3. Can you switch the order? Say, I got $3, but it costs $1.40. Just keep the negative sign for your French fries. So you're subtracting now. You got a subtraction problem. Line up the decimals. Uh-oh, what's 0 minus 4? Well, you're broke. What's 10 minus 4? 6. 2 minus 1. So ladies and gentlemen, this will be what? Is that positive or that negative? So put plus 1.6. Here is your final answer when you have polynomials with decimal coefficients. Is it easy?
Yes.
What are you guys going to do for homework tonight? Add, subtract what? The polynomial worksheet. It's online. Okay? All right. So remember, tomorrow's Halloween. You're going to bring your costume? Anybody going to bring their costume?
I might, maybe.